So we finished up on this slide talking about the alternates. We're going to lay a little bit more groundwork relative to these alternates, and then we're going to walk through them individually and show you the cost. First thing to point out, or additional groundwork to point out, is the water distribution system analysis. Pete referenced this in his opening remarks and mentioned that we're going to talk about this. We're just going to briefly mention it here. We did do the analysis of the existing system. Basically, we're looking to see if there's any conveyance or transmission issues. We're trying to make sure that we're meeting the fire flow targets that you want to hit in the different land use areas. Overall, we're also making sure that there's redundancy in supply and storage. We're happy to report that your existing distribution system is very robust, and transmission of water across it is pretty efficient. The Waterworks system model looked like this when we started. We had been working with it, up to only a couple years ago. We then went through and made sure that it was fully up to date with all the new development, got in the appropriate pipe sizes in any of the new facilities, and then we built the undeveloped areas into it as well. So we've got a full model of existing plus proposed. If there's something different, a different type of land use were to be suggested to come in an area, for instance in this undeveloped area, pretty easy to modify the model to see how that affects things. This is just a summary of one of the alternatives. It ends up being the subregional analysis. So again, we evaluated the three alternates within the system in the future. The subregional is, we'll show you in a second, is bringing the water supply in along Orchard Road, and then once it gets into the system, it has to transfer across. So these spines are needed to increase the pipe size to have the efficient transfer of water going all the way across the system long term. Okay, so that was it on water distribution for now. Let's get into the sub-regional analysis and walk through this. We have to build the water demands just like we did for you, but for all three of the communities so that we can combine those together and determine what the needs are for that. So Montgomery, you obviously know, because we already talked about that, your planning area. Yorkville ends up being the largest of the three. Their overall planning area is just under 73 square miles right now. Their existing corporate limits take up about 20 square miles within that planning area. Oswego is in between both. Their planning area is around 40 square miles, and their existing corporate limits is around 15. This is a summary of population, current and projected. The current population in this table, the 28,346 for Montgomery does include the 9,000 residents in Boulder Hill. So it's really the population that your Waterworks system serves. Yorkville's current population is just under 20,000 and Oswego under 35. So the total of all three is just under 83,000. The CMAP 2040 projections are listed here, which would have put you at 161 if we use their projections as they applied these annual growth rates. When that population number was shown to village staff, they said, I wonder if we could actually fit that large of a population within the remaining portions of our planning area. And the community development staff went through, took the land use plan against your planning area and computed what the max capacity based on that plan is and determined that the 42,000 in total, so that would be 33,000 roughly for the village, plus the 9 of Boulder Hill gets you to 42. So then we reset that number at the 42, which you saw earlier. For Yorkville, if we carry the 3.2% out that CMAP was using to 2040 to 2050, we get upwards just shy of 60,000, and Oswego is just shy of 91. So the combination of the three gets us into the 192,000 population range. Very similar in size to what the city of Aurora is now. This graphic just shows that population growth historically and then projected into the future with the different, certainly growth rates, differing growth rates across each community. This then is the projected water use. So again, using the same approach for current trends, applying the 90 gallons per capita per day out to the 2050 population gives us the 17.33 as the average day demand. Using the less resource intensive gallons per capita per day, which varied across the communities, you guys were 72, Yorkville was around 80, and then Oswego ended up being in between because they have different levels of water loss or they have different levels of irrigation or outdoor water use. Those were factored in to get the sum total. The max day, again, is the important parameter here, the most important parameter because many of our facilities are designed for that. Under current trends, we get just under 33 million gallons per day, but under less resources, we get under 25. Once the system is set up or all the facilities are set up to meet those demands, we need a way to apply the cost to the communities. And since the size of these facilities are based on the maximum day water use, that seems like the most logical parameter to use to apply the cost to the communities. The pie chart on the right show what that distribution would be under a current trends water use scenario as well as an LRI. They're very similar overall. In rough terms, Oswego, based on their 90,000 population and the max day for their community, would have about 47–48% of the cost. Montgomery, obviously being a lower population and a lower maximum day demand, is downwards in the 20 to 22% cost. Again, the maximum day demand of sum total for current trends was just under 33 million gallons per day. We decided to set up a water treatment plant that would be 32. It's a good round number to work with for setting up a water treatment plant. Whereas for the LRI, it's just under 25. We chose 25 for that particular water treatment plant, which would be the source, obviously, to be able to get 25 MGD to the plant, and then the treatment to be able to treat it and ultimately distribute it. I want to talk a little bit about water quality. First, we're going to talk about raw, then we're going to talk about finished. Each one of the communities have deep wells. The hardness of those deep wells would generally be this light bar coming out. So the hardness in Yorkville, for instance, deep wells is upwards of 250 milligrams per liter, slightly less in Montgomery and Oswego. Now, Montgomery has the shallow wells too, which are of higher hardness, so that's why your raw water hardness is higher than the other communities. For reference, this is what the hardness of the Fox River is. It's seasonal. In the winter, actually, it ends up being the hardest, but it's somewhere between 300 and 400. So for you guys, it's kind of right in the range. For the other two communities, it's slightly above or a little bit more above overall. Currently, though, from a finished water quality, the water that you actually distribute out to your consumers, both Montgomery and Yorkville soften their water in their treatment plants. So your hardness is a lot lower, on the order of 70, 80, maybe up to 100, 125 milligrams per liter. Oswego, while they have the deep wells and they have treatment in place to take care of the radium, because they have radium and they need to treat for that, the treatment process that they use does not soften the water. Being that both Montgomery and Yorkville residents currently receive soft water, and putting in a treatment system to soften versus just treat the Fox River, the increase in cost is very minimal. We felt like it made the most amount of sense to set up a treatment system for the Fox River water and any other sources that does in fact soften the water. So for you guys, your residents would have a very similar water quality. For Yorkville, same deal. For Oswego, they would have a significantly better, as far as hardness goes anyway, water quality that's transmitted to their house. This is just a quick schematic of what the water treatment plant would look like. I know you really want me to go unit process by unit process, but I'm not going to do it. The sources of water are on the left, Fox River, of course, coming in, and then all the backup wells would be coming to the facility as well. The main treatment system here, the Claricombe process, that's exactly the same treatment process that you have at your lime softening plant along Nell Road. The back end has the most current technology relative to filtration. For a Fox River water treatment plant for the village of Montgomery on its own, you can actually use the filters that are there. They have to be modified some based on the media. If we were to put in a new sub-regional treatment plant, the filters would be slightly different. After treatment, the water would be stored, and then you'd have to pump all of that treated water from that treatment plant location to each one of the communities, and we're going to show you in a second schematically how that works. Before we get a little farther, switching from one source of supply to a surface water supply may ring a little bit of a bell back in your mind, and I'm talking about Flint, Michigan. So certainly there was some unfortunate circumstances up in Flint, Michigan where they changed their source of supply, and unfortunately the water quality was to the point where it became corrosive and unstable and caused some lead issues, lead leaching within their system. Here to say that that won't be an issue for you. It is not an issue, to our knowledge, for Elgin or for Aurora. The corrosivity or stability of the water is related to pH, alkalinity, and hardness. The treatment system I just showed you has the ability to manage all three of those parameters. So you set up the treatment system to have a stable water. There won't be lead levels that are detectable in the effluent from the water treatment plant. The treatment plant would take out any lead. So if there was lead in the Fox River or any of your wells, the treatment process will take that out. And that was actually probably the case in Flint, Michigan, too. On top of managing the stability of the water that's distributed, we would add phosphate, which is the suspenders to go along with the belt of managing the chemistry. The phosphate coats the interior of the pipes. It would coat the lead piping, etc., so that even if the water was a little bit corrosive or a little unstable, it can't get to the lead to leach that into the water, which is what has occurred there. Again, the treated water that's sent into the system, it's our understanding that doesn't have lead in it. It's just corrosive, so the lead pipes, it's leaching the lead into the water there and unfortunately coming out of the faucet.
In the regional, would this be water coming, say, downriver, wherever our regional thing is? Would it still go to our plant on Nell? Or if that gets lead, then all three cities will get lead?
The sub-regional approach, because of the treatment system and what we'll show you, is we're suggesting that the best approach is to locate a water treatment plant centrally, for one water treatment plant centrally for all three of the communities. You would treat the water there, and then you would distribute it up to the communities. Under the sub-regional approach, you wouldn't have any treatment plants that would be operating. And that's basically because of the economy of scales that are achieved by doing that, having one larger plant versus multiple smaller plants.
And that affects even if our backup system of the deep aquifers? That all would come through?
The deep aquifers would have to come to that as well. And we might have that schematic next. It's coming up. It's next.
Okay.
So this schematic shows you how that backup supply network would be connected. And first of all, again, we need to find a location that's centrally located to bring the backup supply to it. A good location, of course, to pull from the Fox River. But then after we treat the water, it has to be distributed back to the communities. So the more centrally it's located, the easier or more efficient that you can bring the water there and send it out. So the location that was selected, hopefully you agree, centrally located within the planning areas of the three communities, generally would be at the Orchard Road, Fox River intersection. There's not a particular piece of property that's been established. It's just at this point in that general area, and it would depend on, what property could be secured at an appropriate price. But if you put the treatment plant there and then you tie in as many wells as you can within a reasonable distance from it to get the backup supply. First, going up Orchard Road, you could pick up a couple of Oswego's wells. These are existing wells for Oswego, 11 and 6, which are in the green circles there. You could run a spine to the west that picks up 2 of Yorkville wells, 8 and 9. You could run another spine all the way to the west. The city of Yorkville has established a site for a new well number 6, which is right at that north elevated tank on Route 47. So that would be that farthest west well. From that spine, we're suggesting coming north to pick up a future Village of Montgomery well. It would be well number 17. You have a site located along Dixon Road or in the subdivision along Dixon Road where well number 17 can be drilled. Would also come up 14 and 15. Those are existing wells. You already have the raw water main in between those 2 wells, so you just have to tie in to that water main to bring those back. At the water treatment plant, that's the cheapest spot to locate a new well because you don't have to transmit it in one of those mains. You can simply send it right into the water treatment plant. So another well is needed there to have sufficient supply to meet the average state demand in 2050. Plus, Oswego has a couple more wells on the south side of their community that could be picked up and brought to a central water treatment plant as well. Next exhibit then is how will, once the water is treated, how will it be transmitted back to each one of the communities? So as mentioned, you guys have 3 pressure zones across your community. Yorkville has 4 and Oswego has 3. Well, when we pump this water out to a zone or a portion of a system, it has to meet the hydraulics of that zone. So we did this exhibit to try to find zones that were similar in hydraulics so we could minimize the number of pumping galleries that were needed at the water treatment plant, and we think that it can be accomplished with 2 separate pumping galleries. Here's the centralized water treatment plant at Orchard and the Fox River. One line would come north up Orchard Road. That's our suggested or most direct route to get to the Village of Montgomery system, connecting in, again, along Orchard Road there. And that would be the red pumping gallery. The orange pumping gallery would come over and feed Yorkville. So in this instance, if the water treatment plant was south of the river, you'd have the Fox River crossing, and then going west to Yorkville. Off of that spine can also feed Oswego's west pressure zone. To the south, did something come up? There it is. Oswego also would have another feed down coming off of the water treatment plant here. And then Oswego would be able to come off of the red pumping gallery for transmission of the water to their zone as well. The cost associated with how much flow is provided, max day flows in each one of these pipes is distributed to each one of the communities. Yours is the simplest because you're the only one in this pipe, so the full cost of this pipe was applied to you in the cost estimate. For these other ones where it's shared between Yorkville and Oswego, a portion was applied to Yorkville, a portion was applied to Oswego. In the future, as Yorkville grows and gets a little bit closer, a second source would be provided to them. So there's built-in capacity in this pipeline that would current day meet Oswego's demands, but someday in the future meet a portion of Yorkville's demand, and that cost was applied to them in the overall cost estimates. So again, dropping back just to summarize, and we're going to hit each one of these alternatives with some quick summaries and then get into the cost. Alternate 1 was the deep sandstone, continuing as you are more or less now with deep sandstone wells, cation exchange treatment. Alternate 2 was if you go on your own to the Fox River, put in a lime softening treatment plant, and alternate 3 was if you went together as a subregion to the Fox River. The exhibit to the right summarizes the LRI improvements. We talked through pretty much each one of these, but in summary forms for current trends, you need 2 new wells. For LRI, you don't need any additional wells. For current trends, you would need a new cation exchange water treatment plant for well 17. Well 16 would actually come to the lime softening plant. No additional storage is needed in either case, and then there's water distribution improvements. The red boxes here are pointing to improvements that would be needed as part of that alternate. Alternate 2 for the less resource intensive is summarized again in exhibit, as well as text form there, 2B on the exhibit. So here would be the Fox River intake, and if it was current trends, you have to expand your existing lime softening plant. Your existing lime softening plant is rated for about 5 MGD. So if water use were to progress, you would actually exceed that. Therefore, the plant would need to be upsized to 7. But for the LRI, if you can keep those peak demands down, you actually don't have to expand the plant. Now, some improvements will be needed at the plant to be able to treat for the long haul, but you wouldn't actually have to expand it. No additional storage in this case, and then the water distribution improvements to go along with it. Alternate 3, you would have your portion of the Fox River intake, of the backup well supply network, your portion of the treatment plant. For LRI, it's a 25 MGD plant, and then you'd have the internal distribution system improvements to convey that water from the west side to the east side. This is a summary of the cost. Oh no, looks like the font size got a little bit messed up in the transfer from things. Apologize for that. I guess I didn't get all the way to this slide. I fixed some of them. So the first column is the capital cost, and actually this bottom one here should shift to the left. On the handout, it I think is organized correctly, so you can see it there. So again, the bottom one here for 3B should have a capital cost of 43.7, and then the present value should be the 53.3. So with these alternatives, what you can see is in some cases the capital investment may be a little bit cheaper, but the annual operation and maintenance cost ends up being more expensive. The way to combine those to see what is the most cost-effective alternative into the future is looking at the 20-year net present value. So it takes into account 20 years of that annual O&M, adds it to the capital cost, and comes here. So if we look at, for instance, 2B, which is the village of Montgomery going on your own to the river, the capital cost is $29 million. 3B, which is going with the subregional, is $43.7 million. But from a present value perspective, it's 48 versus 53. So it gets much closer because the economy of scale of operating a larger facility is pretty significant. 1.67 per year on your own with your own people. If you combine with others, it's about half of that for your share. We talked about the fact that we would quantify the difference between current trends and less resource intensive. So you would see a $10 million savings on capital costs there, 5.7 on alternate 2, and 4.1. On the present value, it ends up being even more, 14.8, 6.5, and 5.8. The other thing I want to point out, again, we talked about the 20-year net present value. Well, that water treatment plant is going to be there for a heck of a lot longer than 20 years, right? I mean, after 20 years, you're not going to close up shop for the village. That's going to have to continue in the future, and that economy of scale will continue to apply. We then ran the numbers for 40 years, and while it doesn't fully tip the scale yet to where the subregional will be cheaper, it gets even closer. So now there's only a $2 million differential, which from a percentage perspective is certainly within the range of cost estimates. So ultimately, I think you can conclude, or at least I did, and hopefully you believe me, that 2B and 3B are very similar in long-term costs, pretty much the same. You may be asking yourself, well, that's great, interesting about the village of Montgomery, but I am kind of curious how it looks for the other two communities, Oswego and Yorkville. This slide attempts to summarize that for you. They too have the option of going to the Fox River on their own or joining you and the other community sub-regionally. The graph to the right summarizes the capital cost in light blue for each of the communities to go on their own. The dark blue right next to it is their capital cost if they go in sub-regionally with everybody else. And as you can see across the board, it's actually a little bit cheaper, even for Oswego, to go on their own from a capital cost. But when you factor in that annual O&M, which is the green lines, the light green being the 20-year net present value on own, and the dark green being sub-regionally, the scale certainly tips. So Oswego, significantly cheaper to go in as a group. Yorkville, very comparable. In Montgomery, potentially slightly less in the short term, 20 years being the short term. Longer term, it gets very close overall. So what is this going to mean to a resident? And it's hard to kind of put this all together and have an apples to apples comparison. So what we thought might be the best apples to apples comparison is, you know, if you guys are going to move forward with this and you're going to organize as a sub-region and develop some sort of governance structure that makes sense, it might look a little bit like a Lake Michigan system where they combine together, they have a supply and maybe even treat it and then distribute it out to communities, or they get the true water and then ultimately distribute it. So we looked at, it's going to take probably a minimum of 9 years to implement an improvement of this size. So looking at numbers today isn't really a good way to do it. We projected everything out to 2025. We did that by taking capital costs, projecting them at 3% out into the future. Then we took the water rates for several Lake Michigan suppliers, CLC Jawa, Central Lake County Joint Action Water Agency, which is up in Lake County, Libertyville, Vernon Hills, Mundelein, Grays Lake, etc. DuPage Water Commission, what might their water bill look like if we project their rates out at 3%? Some of these folks, DuPage Water Commission, NSM Jawa, IWC, which is who provides water to Plainfield, they buy their water from the city of Chicago. So whether or not a 3% increase is appropriate, it's probably conservative low based on historical movement in their rates. But if you do that, what you see is you guys are cheaper to kind of significantly cheaper than a lot of those folks. Ultimately, based on the supply, treatment, and transmission cost, you would be able to provide water to your community cheaper than most Lake Michigan supplies in the area. The one thing to point out here is there is a second cost that would come with this, that would be the operation of your distribution system. This, again, for an apples-to-apples comparison, is only looking at supply, treatment, and transmission. So if this were to occur in 2025, and a resident brings in and says, my water bill is not $30, it's more than that, it's going to be, because you have a cost associated with managing your distribution system that will be applied on top of that, just like every one of these other systems does too. DuPage Water Commission provides water to, say, Elmhurst. Elmhurst has to operate their water system. They apply a charge on top of that. Plainfield applies a charge on top of the IWC's charges too. As mentioned, probably about a 9-year process. These are the general work items that we think make sense if you do want to move forward, or at least start to consider moving forward with the sub-regional. Because it's a 9-year process, there's certainly time within that process to reevaluate. One of the first work items is probably to talk about governance. So would you organize as a Jawa? There's going to be some positives to that, and there might be some negatives. Would you organize as a water commission? How about as a water authority? Might you get started by doing an intergovernmental agreement so that you can move forward on some things such as land acquisition? So if you think this might make sense, does it make sense to start looking now to buy that property? It might be a little bit cheaper now than it would be if you wait 5 years. Can you find 15 to 20 acres or possibly a little bit more for this water treatment plant? But then might there be the possibility of finding land for other projects that you're working on jointly with other communities? It's our understanding there's some discussions about doing a joint fleet maintenance garage across all 3 communities for the benefit of all 3 in the economy scale with that. Well, might you be able to cite that at some property that you acquire and then long term be looking at doing a water treatment plant on that. Once the land is generally defined, we suggest some water quality testing to confirm exactly what the Fox River water quality is in that area. Aurora and Elgin have been very kind in sharing all of their water quality data, but it would be good to test at that location. Then there might be a need for some pilot testing. So we have the specific water quality. We can bring up small-scale treatment systems to confirm that the effluent from the treatment process that we're defining meets our objectives. After that, then we've got enough information to move forward with the design engineering, which again, this is in the middle of the process. So if you get down the road, and even if this, delays a couple years, 5 years, whatever makes sense for you, you can reevaluate. So if population growth didn't go as was projected, instead of a 25 MGD plant, maybe you're looking at a 22. Or if somehow there was a lot of growth and it was a lot quicker in other communities, maybe it needs to be larger. But there is, again, opportunity to reevaluate. Project financing will be critical, probably can be started at any point, but you really want to have some good numbers to work with to start talking about it seriously. Are you going to do a 20-year bond? Are you going to do a 40-year bond? Are you going to do low-interest loan? Are you going to do a combination thereof? Permitting and bidding, of course, will be critical, and then construction we think would be multi-year. You probably wouldn't try to drill all the wells, put in all the water main and transmission mains and the water treatment plant all at once. You'd probably phase that, maybe drill some wells earlier overall so you can get those all set up such that when the treatment plant is moving forward, those are available to be able to pump to it, to test it, and be ready to go. If you went on your own, just because it's kind of smaller, you're controlling things on your own, it'd probably be 1 to 2 years less to go to the Fox River, bring that water to your existing lime softening treatment plant, and do the modifications there that we've already discussed.
What about your traditional residential water bill? I mean, you have it here where it's together, but what would it be if we did it on our own?
If you did it on your...
Like the next, like that one right there. That's with 3 of us going in.
Right.
But is ours by ourselves going to be
Be a little bit less than that.
a little bit less than this?
It'd probably be comparable because of the net present value, although we didn't run that number. The capital's lower, like we showed, but your annual O&M is higher, so it would be the combination thereof. So I would have to say it's probably going to be pretty similar for you.
Yeah.
You'll have a lower debt service, but you'll have that higher annual O&M.
What's the,
Okay, so decisions.
Jeff?
Oh, I'm sorry.
well, it could wait too. What's the potential to share a groundwater well with Sugar Grove?
We have not looked into that. There's certainly a distance consideration, for one, to be able to get down to your system. Sugar Grove currently has 4 deep wells, going by memory, and 2 or 3 shallow wells. Their plan is to integrate some more shallow and some more deep.
See, they're likely to grow toward us the way I see it.
For the shallow, the thing is, while that well field that we showed on the pink dots, will have, certainly some sustainability. It will have sustainability likely for them, but it's not big enough probably to be able to be sustainable to put a sufficient number of wells to serve their needs and somebody else's. So, I think that might still run into problems being able to put in a well field large enough to be able to fulfill your needs too. And then, their secondary source, of course, would be deep, and tapping into that. And while you're a little bit farther north, you're still certainly in the Kona Depression, and there would be some sustainability concerns with that up there too.
Kind of along those same lines, what do, we have this benefit of being on the Fox River. What do communities just west of here that don't have the Fox River, what are their options when they have the same presentation from their engineers? What are their options for water in the future?
So just west, if you take Hinckley, for instance,
Mm-hmm.
they're far enough west that the deep aquifer, while there is drawdowns that have occurred there, it's nowhere near what it is in this major cone of influence or cone of depression. So, they unfortunately don't have shallow resources that we've seen out in that area, at least right in their current area. There could be some on the fringe. As you continue to work north, like we did Huntley's master plan up in southern McHenry County, and we did the same modeling with the Illinois State Water Survey, because you're away from the cone of depression, deep aquifer withdrawal for them is the best long-term approach, meaning within their planning time frame. We also looked at Lake Michigan water for them for connection. Fox River is not an option in Huntley. Moving west from there, Hampshire, again, up in that area, generally deep wells without the need for the Fox River. Elburn, up in, north of you, is primarily deep wells right now, again, but they're north. So once you get out of kind of the Aurora, Joliet area and go farther north and certainly west, it gets better.
Okay.
So while no decisions are to be made tonight, one of the big picture items that we really want you to think about, and it would be nice at some point to get some direction so that we can finalize the master plan approach with the approach that you believe is a viable long-term solution for you right now. The first step is do you believe that the existing village groundwater sources are sustainable for the long term for the community? If you say yes, then you continue using the existing groundwater sources. If the conclusion is no, there's pretty major concerns relative to that, then the choice, based on what we've shown, because other options are not viable, is to switch to the Fox River with groundwater as the backup supply. From there, you have the two options. Number one, construct the facility on your own, or construct the facility as a subregion. So there's a ton of information here. Holy moly, it was 2.5 hours of discussion. Yorkville's going to be jealous. We think probably some additional discussion will be required of you guys, yourselves. There may be a need, or it might be appropriate for you to get together with Yorkville and Oswego to talk about this, whether it be one or a couple folks from the board, just to hear what their thoughts are, how viable it may be, whatever you guys think. At some point, though, again, it would be great if you guys could select what you think your long-term water supply and treatment solution is, because then we can finish the report. I mean, if we don't know which alternate you're going to choose, we can't set up the implementation plan. With these reports, we typically set up an implementation plan that defines your CIP for the planning period. So from a budgeting perspective, you know that in 5 years you have to do this. In about 6 to 10 years you have to do this, etc. That will look pretty different depending on which alternate you choose. Secondarily, the connection fee. So how you establish your connection fee is quite different if you choose an alternate 3 option versus an alternate 1 option. Time frame's up to you.
And going back to the slides, and maybe I missed it, there's a map here for the sub-regional backup system and the location over at Orchard Road and Box. If we were to go on our own, where's that location
That
proposed?
generally south of Ashland, right along the river. If I can get to a map, I can show you
And Ashland.
better. It's probably not.
We're up here with the tripod.
So Ashland Avenue Bridge, just south of there, there's actually a well at that site for the village as well. Probably requires some property acquisition in that area, but we were thinking that that would be a good location, partially because your raw water main that takes there's one well on the west side and 2 on the east side, comes through that area and then back. We would have to run a second water main along with it. The other part that we like, or the other reason why we like that opportunity is you're upstream of the dam. So the water level is essentially controlled by the dam. You know, it might
Somewhat.
go up and down a little bit, but if you're downstream of the dam, it could get pretty low and that could affect things.
Okay.
Yeah, it definitely gets lower. I can see Oswego and Yorkville saying this is great because that location you're pointing out is 2 miles from downtown Yorkville, 2 miles from downtown Oswego, and it's umpteen miles to us. If we put one in by ourselves, would we do it the same as Aurora, still use our regular water and use the Fox just when we need it? Where down there, I presume we'd be using it all the time. And like you said, we wouldn't be using our own wells, but, right? Somebody talk to me.
Yeah, so I think about using the Fox Rivers, you can't switch it on and off as easy as you can the cation exchange units, because you really need to operate a surface water plant 24/7.
How does Aurora do it? Because they use it more.
They operate the Fox River 100% of the time, but it may only supply at any given time 70% of the water for the city.
Okay.
But they're always running the Fox River plant. So they're always taking water out of the Fox River. They run 24/7, and that's so that you can monitor the water quality of the river continuously so that you make sure that you're meeting all the standards. They add to it then deep or shallow wells that they have to, they'll do it for a number of reasons. It might be temperature control. Like in the summer, if it's real warm, they might blend some water in to cool it down. If there's an algae bloom on the river, for example, they may have to back off the supply of the river and use more groundwater. So I think we would use a similar strategy.
In the sub-regional, you use a similar,
Yeah, you would do the same thing, and if we did a plant ourselves, let's just say we did one ourselves, we'd use the exact same strategy. We would operate it as much as we could on the river water, and we would add some additional wells as needed when we needed it. So, it'd be the same general approach.
Awesome. Any questions for Jeff? None?
Thank you.
One thing that I wrote down from the beginning was one of your quotes was, "We cannot run out of water," and that's probably one of the most important things. Should have been the first slide. It is not an option for us to run out. So I appreciate the very lengthy discussion on it, and this is the beginning of what I hope to be many, many conversations about the future of our water supply. I know that makes everybody really happy, but so yeah. Thank you. Anything else from anybody? Review this again tonight before you go to bed.
Mm-hmm.
All right.
Lauren, you awake? Okay.
All right, if that's it, we don't have any unfinished business. Future board meetings, we canceled the May 23rd meeting, so our next meeting is not until June. We do not have executive session. I'll entertain a motion to adjourn.
Second.
Trustee Hines? Trustee Youngerman?
Yay.
Trustee Marisak?
Yes.
Trustee Bond?
Yes.
Trustee Spurling? Trustee Lee?
Yes.
And we're adjourned. Thank you.